My name is Izzati Binti Azahari. I will explain about the characterization and antibacterial activity of silver nanoparticle synthesis with the mangosteen peel extract.
Presentation outline will consist of introduction, literature review, methodology, results and discussion, and the last one is conclusion and recommendation.
The background of study, the biosynthesis of silver nanoparticle has attracted a lot of attention in the field of nanotechnology due to its antibacterial and biomedical use. The green synthesis of silver nanoparticle is a novel way to synthesize nanoparticle by using biological source. The Garcinia mangostana is used in this study as the reducing agent and their antibacterial properties were assessed.
For the problem statement, there are 3 points. The first one is the high level of radiation and toxic irritant if you use chemical and physical synthesis. The second one is the food waste in a global food supply chain. And the third one is antimicrobial resistance developed.
For the significance of study, the extraction of mangosteen peel extract can be used in more beneficial way in skin aging, and it also can be used in medical scope. And it also can minimize infection, reduce the spread of antibiotic-resistant microorganisms. The biological synthesis is easy, inexpensive, and relatively repeatable, and it usually results in more stable materials. The objective of this study is to biosynthesis and characterize the 7 nanoparticles synthesized from mangosteen peel extract and for to determine the antibacterial activity of mangosteen peel extract mediated green synthesis of 7 nanoparticles. The mangosteen, Garcinia mangostana, widely known as one of the most appreciated tropical fruits and undoubtedly the most respected fruit in the Gutterae family. And the mangosteen includes compounds that may function as antioxidants and infection-fighting agents. The mangosteen peel includes phenolic acids and flavonoids which have biological and therapeutic characteristics including antioxidant capabilities. The pharmacological action of xanthones have been identified, including antibacterial, antifungal, and anti-inflammatory activities. The silver nanoparticles are utilized to inhibit microbial development for a variety of commercial purposes. Hence, the silver nanoparticle will demonstrate antibacterial properties of silver ions are exploited in antimicrobial applications.
These are the overview of methodology. The first step is the sample collection and extraction, then proceed with the green synthesis of silver nanoparticles, then proceed with the characterization of synthesis of silver nanoparticle, where it consists of 3 methods. The first one is UV visible spectroscopy, scanning electron microscopy, and the last one is Fourier transform infrared spectroscopy. And proceed with the antibacterial assay, and the last one is statistical analysis. Then for the sample collection and extraction, the first one, the mangosteen peel extract powder was purchased online from ANT Ingredients Sedang Berhad. Then 5 grams of mangosteen peel extract will dissolve in 10 milliliter of distilled water, and the extraction solution was kept in the refrigerator for later use. For the green synthesis of silver nanoparticles method, the first one is 0.17 gram of silver nitrate powder will dissolve in 10 ml of distilled water to form 0.1 molar of silver nitrate salt solution. Then, as in this study, we used 2.5 millimolar silver nitrate solution, so 2.25 ml of 0.1 molar of silver nitrate salt solution was added into 87.75 milliliter of distilled water and add with 10 ml of 0.5 gram per ml mangosteen peel extract with 90 ml of 2.5 millimolar silver nitrate solution. Then the mixture was kept at the room temperature for 24 hours and the color change of the mixture was monitored and recorded.
Next, for the characterization of synthesis silver nanoparticle, we'll be using 3 methods, which is UV visible spectroscopy analysis, scanning electron microscopy, and the last one is FTIR.
For the antibacterial assay, there were three steps. The first one is the preparation of neutral agar and neutron broth. The neutral agar we use to pour into a sterile disposable petri plate, and while for the neutron broth, we will use to the preparation of inoculum. For the preparation of inoculum, we use to isolate a colony of E. coli and the billiken with the sterilized inoculation loop and transfer in the same bottle. For the there are three tubes. For the first one is tube A, and tube B was incubate within 80 hours, while for the tube C was incubate within 2 hours to check absorbance. For the bacterial suspension should then be compared to the 0.5 McFarlane standard between 0.08 and zero point 0.1. For this diffusion test in this study, we used three different concentration of sample mangosteen peel, 7 nanoparticle solution, which is 100%, 75%, and 50%. In the study, for the negative control, we use distilled water, and for the positive control is antibiotic and penicillin. Then for the result for green synthesis of silver nanoparticle, the color had changed from soft pinky to dark brown color after 24 hours of incubation. The colloidal solution shift color to dark brown from soft pinky, showing the production of silver salt and Garcinia mangostana peel extract solution. This gradual coloration confirmed the beginning of the reduction process. The color change is caused by the surface plasma resonance excitation effect.
Then, for the result for UV visible spectroscopy, the UV visible absorption spectrum was recorded in the range of 200 to 800 nanometer wavelength. In the spectrum, a wide surface plasma resonance phenomenon peak was spotted at 472.9
Scanning electron microscopy (SEM) of mangosteen P silver nanoparticle, the spherical silver nanoparticle were observed in SEM pictures, and the capping agent suggests that the nanoparticle was stabilized because there was no indirect contact even when aggregate. The most particles range in size from 10 to 50 micrometer. Thus, for the Fourier transport infrared spectroscopy, mangosteen P silver nanoparticle result, this graph shows the absorption peaks ranging from 660.12 to 3,308.95 centimeter was observed. The peak is moved to a higher wave number site at 660.12 centimeter of the extract, which attribute to amino acids. Antimicro activity results. The evaluation was done by measuring the zone inhibition of 10 microliter of silver nanoparticle and is efficient on Bacillus licheniformis gram-positive bacteria in E. coli gram-negative bacteria. The maximum zone inhibition of positive control is E. coli, which is 14.1 mm plus minus 0.24 mm. The B lichen is fuzzy edge zone inhibition because it might be some technical while doing the process of this diffusion technique. There are no inhibition occur at negative control, and the E. coli gram-negative is more susceptible because gram-negative bacteria were slightly resistant to nanoparticle than the gram-positive bacteria.
In the conclusion, the silver nanoparticles were successfully biosynthesized using Garcinia mangostana and could be extract as reducing agent and capping agent, which is an eco-friendly, cost-effective, and non-hazardous greener approach. Then the biosynthesis of silver nanoparticle in the current study show antibacterial activity against E. coli in Licheniformis, which is suggests that they may be useful in developing new drugs. There are a few recommendations to this study. The first one is to further analysis the characteristic of mangosteen peel silver nanoparticle is recommend carry out transmission electron microscopy (TEM) to view more specific and details on the morphology and size of the particles, and then can also use a different bacterial strain, gram-positive and gram-negative. The last one is to recommend to test on anti-inflammatory drugs since mangosteen natural phenolic is antioxidant and is a natural compound such as xanthos and benzophenines have advantage as potential therapeutic candidates for inflammatory disease.
That's all from me. Thank you.